Hello. One of our most recent project involvements has been a project which is a feasibility study around smart grids in a city context. And what was nice with this project was that we got a lot of opportunities to think about how our future energy use will look like. And I think this is a really intriguing question. Where are we headed in terms of our energy use? And as you might have heard, a lot of people are talking about that we're approaching something which is similar to an paradigm shift in terms of our use of energy. But before we start talking about where we're headed, I think it's reasonable to also ask the question, where did we come from and how do we use energy today? And I made up this slide, which I think can in some way represent these kind of transitions that were made. And when you start looking at these pictures, you immediately think of how many aching backs and hours of hard work that this kind of new technology that we apply today have saved us. But there is also one other dimension to this. And if you look really careful here, it's not a good resolution on this picture, but it looks almost like she's smiling when she's standing there. And she looked kind of proud to me. I think almost, like a mountaineer or something. And the point I'm getting at here is that if we take an experience perspective on this, what we've done is that we've transformed something that is very complex into something which is very simple. And if we allow ourselves to become a bit philosophical, there's an American philosopher which says that when we apply technology, this is usually what happens. We transform something which is very complex into something which is simple and convenient. And why is this a problem then? Well, as one of our contemporary trends is that experiences are becoming increasingly important. Nowadays, it's said that people collect experiences rather than material wealth, and the things that we possess are more or less vehicles to get these kind of experiences. So what this means is that we actually lose the attention of people. And this has several effects, of course: decreased awareness around energy use, decreased interest in energy-efficient technology, for example. My argument is that there is a design assumption here that users don't want to care about their electricity use. And this causes what I would say reinforcing design loop. So this kind of assumption is reflected in the design, and when we as users interact with these kind of things, it makes us less interested, and this kind of reinforces this assumption in a way. So I'll leave this for a while and return to the question, where are we headed? And the foundations of this smart grid concepts is usually based on this rapid technology development around information and communication technology. That's one part. And the other part is the grand challenges of our time, which forces us into a transition into renewable energy. And as previous speaker also mentioned, this causes a lot of problems. One being that since fossil fuels are actually stored energy, we kind of lose this storage capacity when we turn into new forms of energy production. So we have a smaller ability to respond to the demand for energy, for example. Um, so how does information and communication technology help in this regard? Well, I'll take this example of the washing machine as well. The washing machine has a certain environmental footprint today. And through some technological innovations and development, we managed to increase the efficiency of this kind of product. But if you talk to the manufacturers of these kind of products, they will tell you that we kind of reached the limit for what we can do in this regard. There isn't that much improvements we can do in this area if we don't change the washing machine drastically. And another thing that we could do here is take into account the electric grid and coordinate these kind of systems, the local system with the more global system of the electric grid. And this causes a coordination effect. We use energy when it's available, when it's clean, and when it's cheap, for example. And at the same time, we get some synergies on the electric grid. We get a better balance between production and demand, and we can use a larger percentage of renewables in the electric grid. What's important to realize is that it's not only about information and communication here. There is also business models and other things that needs to be in place in order for this to happen. And perhaps the most important thing is, of course, the user. How do we get people to buy this kind of washing machine instead of something else? This one will be a bit more expensive. And what is important to realize also when it comes to the user is that this kind of evaluation of the technology, it doesn't start when they meet the technology, it starts before that. So the user will start asking questions like, for example, is this useful? Is it easy to use? Is it a good idea? And if you want it in your home, you might even start to consider if it fits into the aesthetics of your home and so on. And a lot of those questions. So I wrote down some of the things I think are important in this regard. And the first, of course, is understanding. We need to provide people with the knowledge so they understand what kind of problem this technology solves. And there's also the question of integrity. And when it comes to integrity, a lot of people are talking about cybersecurity and locking up data from sensors so that people can't be spied on and so on. But I think there's a more political direction to that as well. If the power company were to control your washing machine and your clothes gets damaged in some way, you will become quite mad. If you compare this to if you feel that you are in control yourself, that's another thing. Then you might as well become mad, of course, but in another way. Interaction models is also something important. There are standards for communication that are being developed between the washing machine and the electric grid. But in the same way, we need these kind of standard ways to communicate with the devicer and between the devices and the user. For example, when you turn on the lamp at home, you switch the switch in one direction, the lamp goes on, and in another, and it goes off. If you would change those kind of things, people would be lost in many ways. You have certain symbols on your washing machine which you can recognize on all brands, for example. So this is something that needs to be done in order for users to feel secure with this new technology. Once the user has this technology, we also need to enable them to become this active user that responds to price signals and so on. And I wrote down two things that I think is important for this. One is presence and one is feedback. So presence, we can't just have websites that you need to log on to. You also need a presence in your home where you can see this to some kind of metaphor. If you're using clean energy, or if you're using not so clean energy, if you're using expensive energy, and so on. So for those of you that are familiar with the concept of ambient displays, this is one of the areas where this really makes sense. Another thing is, of course, the feedback. If we do a lot of things, we want to know what the effects of that, what kind of effects we achieved with that. So then it comes to motivation. One obvious way to motivate people is, of course, the cost saving. But I think that's quite an incomplete picture. So I would also like to add what I call the social motivation. And the social motivation can be everything from, for example, being better than the neighbor, or contributing to this transition towards a sustainable society, or being a role model for your kids, and so on. So there's a lot of motivating factors in that regard. Just to be on the safe side, I added this kind of X factor as well. If you look at computer games, for example, there is a lot of pleasures which is perhaps not purely social, or for example, creativity, exploration, and all those kind of things. But to reconnect to my previous discussion is, how do we get people engaged in that if this represents electricity? And I think a key component here is breaking down the boundary between what we perceive as leisure and what we perceive as utility. And one thing as well is bringing out this complexity, or creating complexity around energy use might be a good thing, because it intrigues us, it makes things interesting. For example, this was a project where we made electricity visible in the cord, the electric cord, through flowing blue light. And you could, in this cord, you could see really small details of your consumption. For example, if you played a song on your stereo, you could see the bass beat pumping through it. And you can, when you were drilling to a wall, you could, if you pushed the drill harder, you can see how much more electricity that was used. The harder you pressed, the more it would glow, and so on. So this kind of brought out a dimension of details that really intrigued people when they used electricity. This other example was a game, a mobile computer game, which was connected to the smart metering in people's homes. And they were competing in this game with a certain scenario. And it was really interesting when we interviewed these kids, and one of them really enthusiastic told us about his second cousin's coffee machine that could melt an iceberg in an instant. So this was really an interesting, and we have done some other projects in this team as well, where people had lights in the windows that changed color depending on their energy use, for example, which also created a quite interesting social interaction around this. To end this talk, I'm just going to show you my absolute favorite, and this is a favorite example of breaking down the barrier between utility and leisure. And this is an ongoing project we have where we look on people that make their own electricity. How can we enhance their experience of this? And the visualization you see there is showing as a blue light the electricity you get from the grid, as a yellow light the electricity that you get directly from your solar panels, and the orange kind of is the electricity that you export out to the electric grid that you don't use yourself. So to end this talk, just wanted to say that in order to meet this future challenges, we need to make sure that we design technology that makes sense to people, and also that we might have to reinvent some of the lost pleasures of the past. Thank you.